we want to find the smallest angle in this triangle. Now, the smallest angle in a triangle is opposite the smallest side of the triangle. The smallest side of the triangle is this side here. So the smallest angle must be this angle here. The largest angle will be opposite this side here. The largest angle will be this angle down here. Now, when we're looking for something in trigonometry, we call that something A. If it's a side we're looking for, we call it small a. If it's an angle that we're looking for, we call it capital A. So I'll use this notation. It's just easier to use the formulas with this notation. Now, we don't have any other angle in this triangle, so we can't use the sine rule. As I've explained in a previous video, if we know three sides of a triangle and we're looking for an angle, then we have to use the cosine rule. Because if we try to use the sine rule, well, you can try it, you'll see that you won't have enough information. You'll need one of these other angles. You don't have them. Okay, so let's use the cosine rule. So if we're calling this angle capital A, which is I recommend you do when you're looking for an angle, then the side that's opposite capital A is small a. And the two sides that are given are small b and small c. So the small letters are the sides. So it doesn't matter which you call b and which you call c. You'll still get the same result. The formula is symmetrical in b and c, so it won't matter. So you can look up this formula. This is the version that I always work with. It just saves confusion. We're looking for the angle, and we have small a, b and c. So if you want to, you can plug in the values and then rearrange, or you can rearrange first. Now I'll rearrange first. I bring the b squared and c squared over, so I'm subtracting b squared and c squared from both sides. And lastly, we divide across by this. So we divide both sides by minus 2bc, since minus 2bc is multiplied by cos a. So I'll write the cos a here, and I'll take this quantity and divide it by minus 2bc. So we just fill in the values. Small a is 5.39, small b is 7.81, small c is 8, so we calculate all of this. That's the numerator, it's everything on top, and we divide that by this quantity here, minus 2 times 7.81 times 8. So you can bracket this, and we get 0.767797, etc. The cos function is always a number between minus 1 and plus 1, so this number here should always be between minus 1 and plus 1. If it's not, there's something wrong. Anyway, we want the inverse cos of this quantity. So to one decimal place we get 39.8 degrees. Now let's get the largest angle of this triangle. As I said earlier, the largest angle of a triangle is opposite the longest side. So here's the longest side, so the largest angle is this angle here. So since we're looking for an angle, we will call it capital A. Now we have enough information here to use the sine rule, because if this is capital A, then this is small a. Well, we need that, but we also have a side and an angle that's opposite the side. We can't use this side here because we don't know this angle. So we have to use this side. So we call that small b, small letter for the side, and the angle that's opposite the side is capital B. So the sine rule says that in any triangle, a divided by the sine of a is equal to small b divided by the sine of big B. Now we're interested in sine of a here, so to get at that you could turn both sides upside down. Well, you don't have to, you could also just cross multiply and rearrange, but here's probably another way to do it, maybe a bit easier. Just invert both of these, and after doing that multiply both sides by small a. So you get sine a equals small a sine b divided by small b. So that's just multiplying both sides by small a. So we cancel that a there. So invert both sides. If two fractions are equal, then the reciprocals are equal. Now let's just fill in for this. So we see that the sine of a is 8 sine 39.8 degrees divided by 5.39. Right, so we've 39, we have to get the sine of this, multiplied by 8 and divide this by 5.39. Now we want the inverse sine of this number. So this here is sine of a. Here's the inverse sine of a. I'll write this down to one decimal place, 71.8. Okay, so that's the largest angle. What about the angle whose value is in between? Well, the three angles add up to 180 in a triangle, so I can just add this on to 39.8 and take from 180. Just ignore the minus sign, we get 68.4 degrees. So notice that the angle that's in between the smallest and largest angles is opposite the side whose length is in between the smallest side and the longest side.